In this video, we'll discuss integral exponents. Now that term may throw you off, so what is that? That is an expression where our base is raised to an integer exponent. That's where the word integral comes from this. So let's look at an example here. If I have 5 to the 4th, my base is 5, the exponent is 4, and I say that, just like I just said, 5 raised to the 4th power. And what does that mean? Well, that means I'm going to take my base of 5 and multiply it by itself 4 times. So 5 times 5 times 5 times 5. And if I simplify that, it would become 625. Now let's look at a couple rules about how these integral exponents work. I'm going to use some generic letters to help us, but we're going to assume they're always integers. Again, the counting numbers, positive and negative. So let's start with the most basic rule of integral exponents, which is that if I have one base raised to an exponent times the same base raised to a different exponent, I can add those exponents into one single expression. So I could say that if I had 3 raised to the 5th times 3 raised to the 7th, I could simplify that to 3 raised to the 5 plus 7, or 3 to the 12th. That's a little bit easier to work with. Now what if I had an integral exponent raised to another exponent? I can just multiply my two exponents here. So if I had something like 14 to the 3rd raised to the 9th, I could revise that to say 14 raised to the 3 times 9, or 14 to the 27th. Now what if I had two numbers being multiplied raised to an exponent? I can distribute that exponent to both of those numbers and then multiply. So say I had 8r raised to the 3rd, that means I have to make sure to distribute the 3 to both of my terms in the expression. So that's 8 cubed times r cubed, or often we simplify our numbers, so that'd be 512 r cubed. And this is one of the most important ones to pay attention to distribute that exponent to both terms inside the parentheses. If I can do it with multiplication, I can do the same thing with division as long as my denominator is not 0, because I can't have 0 in a denominator of any fraction. So say I had 2/3 raised to the 4th power, I could revise that as 2 to the 4th over 3 to the 4th. And finally, any number raised to the 0 always equals 1, as long as it also is not a 0 base. So say I had 847 raised to the 0, that will always give me 1. Now all those numbers we just dealt with were the positives. And they apply to negative numbers as well, but sometimes the negatives can seem a little bit more confusing. So let's look at them separately. First, say that my base is negative. All I'm going to do is multiply that same negative number however many times my exponent says. So if I had negative 4 to the 3rd, that means I would do negative 4 times negative 4 times negative 4. And I pay attention to my negatives there to figure out whether it's a positive or negative final solution. This one would be negative 64, because negative times negative gives me positive, and then that simplified positive times a negative will give me a negative. Another example, negative 6 raised to the positive 4th would be negative 6 times negative 6 times negative 6 times negative 6. And when I do all that, I'll get a positive 1,296. Now what if my exponent is the negative? This requires the creation of the reciprocal of the integral exponent to make that exponent become positive. It doesn't change the base, but it makes the reciprocal. So if you remember that word reciprocal, we're talking about the fractions. So here I have positive 3 raised to the negative 4th. Remember, any number is always technically over 1. So when I think about the reciprocal, that means my numerator becomes 1, and then my denominator becomes the integral exponent, and it becomes positive at this point. So 3 raised to the positive 4th. Now if I had a fraction to start with, I go back and think about my rules. Here I would distribute the exponent to both terms in the fraction, and then I'd say, okay, they're both negative. I'm going to make the reciprocal. So I'm going to flip this fraction, which will give me positive 5 to the third positive in the numerator and 1 to the third in the denominator, and that simplifies to 5 to the third. So let's look at it now. What if there's more things in that fraction than just two numbers? I start with the numbers and I simplify them to simplest fraction form. Then I look at my numerator and denominator and say, are there any bases that appear in both? If so, I'm going to subtract the lesser exponent from the greater exponent and keep that variable or that base in where the greater exponent is in the fraction. And finally, I want to look through that entire fraction to make sure everything is positive for my exponents. If I have a negative exponent, I need to revise it to create the reciprocal. So let's look at two examples to finish off. So first, I'm going to start with the 4 over 10. That simplifies to 2/5. Then I see I have x to the 5th and I've got an x in the denominator. Now remember, if it's just the variable x, it always has an exponent of 1. So really I can say that that is 5 and that's a 1. 5 is greater, so I'm going to rewrite that as x raised to the 5 minus 1. Then I look at my y's. And I say I've got a 3 in my numerator, a 7 in my denominator for the exponents. The 7 is greater, so I'm going to do 7 minus 3 in the denominator. This will simplify then to 2x to the 4th and 5y to the 4th. And everything is positive for my exponents here, so I'm in good shape. Now let's look at one last example. So here I have 3m raised to the negative 5th, n raised to the negative 2nd, over 27 m raised to the negative 1st, n to the 4th. I start with my numbers, and that's 3/27. That can simplify to 1/9. Now I'll look at my m's, and this is important. Negative 1 is actually greater than negative 5. So I will place this in denominator, subtracting the negative 5. Same thing with my n's. I have a positive 4 in denominator and a negative 2, so I'm going to subtract that negative 2 in the denominator. Now pay very close attention as you subtract a negative, because that really becomes plus a positive. So negative 1 plus positive 5 is positive 4. 4 plus positive 2 is 6. So when simplified, this becomes 1 over 9m to the positive 4 n to the positive 6. And again, my exponents here are positive, so I have a fully simplified expression.